Hello people and welcome back to Maybe Ismail. In this session we will be doing trigonometry, and this is not just any basic trigonometry, this would be proving trigonometric identities. Okay, now before we dive into the topic, let me just tell you that whatever things I'm writing on my screen which you see, you are not supposed to write all of that while watching the video. You just watch the video and try to understand what I'm trying to explain. And once you are done watching the video, all of these things which I've written over here, they are put up in the description as a PDF notes format thing. You can refer to that thing. I've also put up the worksheet of all these questions that we are doing as like one single PDF, so you can refer to that and solve those questions on your own. Okay, yeah, now let us get into the topic. Now I know that solving or proving trigonometric identities is one of the most challenging things, or one of the most challenging type of questions which students come across in their curriculum. But trust me, this is not that difficult. You just need to follow a few steps, a few well-defined steps, and you also need to know very few basic trigonometric identities and algebraic identities, so that you can basically take the question forward to whatever the answer is required in the question. Okay, let us dive into the topic and let me show you what the things are. So here this thing says that you need to know the few rules that you should follow to basically solve any kind of questions. So there are 5 rules and you have to follow this sequentially. Okay, so the first thing is you have to decide where to start. So there is LHS and there is RHS. You have to decide which side to start from. So the simple rule over here is start from whatever is the bigger side. If the LHS is big, start with LHS. If the RHS is big, start with the RHS. Or you start with something which is complex. So because we simplify stuff in mathematics, so if we have a big complex thing, you just simplify it and make it smaller. So that's the idea. You either start with LHS or RHS, but start with the bigger and the more complex thing. That's the simple rule. Okay, the next one is use any trigonometric identity if possible. Now if you are someone who only knows 3 trigonometric identities, that's good. Use those three trigonometric identities and solve it. If you know more, then use those also, not really a problem. I will show you what those trigonometric identities are just in the next slide. Okay, if any trigonometric identity is not possible, then you look for any algebraic identities if they are possible. Algebraic identities, again, I'm going to give you in the next slide. Okay, if you can't use any trigonometric identities, you can't use any algebraic identities, now the next step is to look for fractions. If you have any fractions, just solve the fractions, basically cross multiply and do all those things with the fractions. You'll eventually end up seeing some identities or something. If you don't have any fractions, also the last step is basically to convert everything to sine and cos. Okay, and then you'll be able to see a few things, maybe a few fractions or maybe some identity or something or the other. Okay, now there is one more thing which I haven't written over here, which is rationalizing, which we will discuss in the towards the end of this video. I think probably we have 2 or so questions in that, so we'll discuss in that. Also this video, I don't know how many episodes I'm going to make out of this topic, because this is a big topic, so we need to maybe 3 or 4 videos on this thing. Let's see. Now let us move ahead to the identities. Now I have a few identities which are algebraic identities. We'll just quickly go through it. A plus b the whole square is a square plus 2ab plus b square. A minus b the whole square is a square minus 2ab plus b square. A plus b into a minus b is a square minus b square, that is difference of squares. Then a plus b the whole cube, a minus b the whole cube. You should technically know these formulas. And the last one is a cube plus b cube and a cube minus b cube. I didn't read out the last 4 because those are not that important and not very frequent, but the first 3 are like super important. You like very frequently see them. Now what about the trigonometric identities? Super fundamental and very important trigonometric identities, that sine square x plus cos square x is 1, sec square x is 1 plus tan square x, and cosec square x is 1 plus cot square x. Now you should know these identities and you should also know how to manipulate them. So basically if I say sine square x plus cos square x is 1, I can send one of the things to the other side. So I can say sine square x is 1 minus cos square x. So you should be able to visualize all of these things and manipulate these identities to solve the questions. Okay, let us try to get into the questions. So here I have my first question and it says, prove that 1 upon tan a plus cot a is equal to cos a into sin a. Now my first step, okay, I will always be iterating the steps, okay, so that you get used to it and you also start doing the same thing. Okay, so my first step is to identify where to start from. So here I see that my left hand side is bigger and more complex, so I start with my left hand side. So left hand side is 1 upon tan a plus cot a. So 1 upon tan a plus cot a. Now what do? Do I see any trigonometric identities? No, I don't see any squares or cubes or any powers, so no trigonometric identities. Do I see any algebraic identities? No, because there are no squares or cubes or anything, so no algebraic identities. Do I see any fractions? No. To cross multiply, I need two fractions. Here we have only one fraction, so that also fails. So the last step is to convert everything to sine and cos. So which means I can write 1 upon the tan A becomes sine A upon cos A, plus the cot A becomes cos A upon sine A. Now in the denominator I can cross multiply the stuff, and the sine A goes to the sine A becomes sine square A, plus cos A goes to the cos A and becomes cos square A, and the two denominators get multiplied with themselves, so it becomes sine A times cos A. Now the denominator of the denominator is sine A cos A, which is this sine A cos A. It is the denominator of the denominator, so it can be written in the numerator. So this thing now becomes sine A times cos A, and I would just ignore the denominator, which is sine square A plus cos square A, because we know sine square A plus cos square A is just equal to 1, and that is basically my final answer. Okay, let us move ahead to the next question. Now this one says, prove that tan A minus cot A is equal to 1 minus 2 cos square A upon sin A into cos A. Now obviously the first step is to decide where to start from. I can see that the right hand side is more complex and it is the bigger one, so I will start with my right hand side, which is 1 minus 2 cos square A, the whole thing upon sin A into cos A. Okay, now just as a side note that I personally believe that Instagram or YouTube shorts, reels, these are basically things which are for entertainment purpose and maybe awareness purpose, but they do not educate you a lot. They just entertain you, or maybe make you aware of few things, or maybe a reminder would be a good thing to say that you get from reels and shorts. But if you have to actually study something, you need to follow long YouTube videos. You need to understand how things work. Why am I saying this? I made a reel on Instagram in which I wrote that maturity is not substituting sine square theta plus cos square theta is equal to 1. It is writing sine square theta plus cos square theta instead of 1. And that reel was absolutely nothing. I just made it in 5 minutes. It was just written on the board, and that reel got 2 million views. Okay. Now that is one of the really important things in trigonometry, that you have to understand that over here, the one which I see is like a super important thing. I know sine square theta plus cos square theta is 1, but I can also do the reverse of it. Can I just say that instead of this 1, I can write sine square A plus cos square A. You see, that reel was just a reminder. You can just remember, okay, there is something known as sine square theta plus cos square theta is equal to 1, but the reverse also works. Okay, so that is what I am going to do over here, that instead of 1, I'll be writing sine square A plus cos square A, and minus 2 cos square A remains as it is. Now in the denominator, I have sine A times cos A. So this is sine A times cos A. Okay. Now if I see, the numerator becomes sine square A, and cos square A minus 2 cos square A is just negative cos square A, and the denominator is sine A times cos A. Now we all should know one simple thing, that if I have A plus B upon C, or maybe let's say A plus or minus B upon C, this thing can be written as A upon C plus or minus B upon C. So if there is a plus or a minus sign in between two terms in the numerator, and there is one single denominator, or maybe a few things in the denominator, the entire denominator goes to every single term in the numerator. So even if I have A, B, C, D, how many ever terms in the numerator, the denominator goes to every single term. Okay. Now the same thing happens over here. This thing becomes sine square A upon sine A times cos A, sine A times cos A, minus cos square A, the whole thing upon sine A times cos A. Now I can just cancel out one of the sine, and I can cancel out one of the cos's from here. So this just becomes sine A upon cos A, which we all know is tan A, and the other one becomes cos A upon sine A, which we all know as cot A, and that is exactly what my LHS is. This time we started from the RHS and we reached LHS. Okay, next question. This one says prove that all of these is equal to that thing. I would obviously start with the left hand side because the trigonometric ratio looks bigger to me. Okay, so the left hand side is cosec raised to 4a minus cosec square a. What do? I started with my left hand side. Now, do I see any trigonometric identities? Kind of yes. Do I see any algebraic identities? Not really. So I should basically use trigonometric identities. But before that, I would just factor out a cosec square a. So if I factor out a cosec square a from both the terms, the first term will still be left with a cosec square a minus the second term will have nothing left, so it is just minus 1. Now, if you know the formula, cosec square theta is equal to 1 plus cot square theta, this 1 can go to the other side and it becomes minus 1. So cosec square theta minus 1 is cot square theta. So cosec square a minus 1 can be written as cot square a. So this is cosec square a times cot square a. Now, in my answer, I do not need a cosec. I only need cot. So what I'll do is I will again convert this cosec square a to 1 plus cot square a. So it is 1 plus cot square a, and outside the bracket I still have a cot square a. Now this cot square a outside the bracket can go with both of the terms inside, and it becomes cot square a times 1 is cot square a plus cot square a times cot square a is cot raised to 4a, and that is exactly what is required in the question. That is my RHS. Okay, next question. This one says prove that sec a times 1 minus sin a times sec a plus tan a is equal to 1. Now obviously the left hand side is bigger, so we'll start with the left hand side. Okay, so this is sec a times 1 minus sin a times sec a plus tan a. Okay, first step. Can I use any trigonometric identities? No, there are no powers, so no trigonometric identities. Can I use any algebraic identities? No, there are no powers, no algebraic identities. Can I solve any fractions? No, we do not have any fractions, which means we have to follow the last step, which is convert everything to sine and cos. So this thing becomes 1 upon cos a times 1 minus sine a, and the sec a can again be written as 1 upon cos a plus the tan a can be written as sine a upon cos a. Okay, so this thing is 1 upon cos a into 1 minus sine a. Now over here I can see that these two denominators are same, which means these are two like fractions, which means I can combine them and write it as 1 plus sine a the whole thing upon cos a. Now in the numerator I have 1 minus sine a into 1 plus sine a, which is difference of squares, which is the identity which I gave you. So a minus b into a plus b is a square minus b square, so 1 square minus sine square a. And in the denominator, these two cos's, this cos and this cos, they just get multiplied and it becomes cos square a. Now in the numerator it is 1 minus sine square. Now we all know 1 minus sine square is cos square, the first identity. 1 minus sine square a would be cos square a, and the denominator is also cos square a. These two just cancel out and my final answer would be 1, and that is what my right hand side is. Okay, next question. This one says sec square a plus cosec square a is equal to sec square a into cosec square a. Just remember one thing, whenever you see that there is a plus or a minus in between two terms and then you have to convert it into a multiplication, the simple rule is just convert it into sine and cos, cross multiply it and get back to whatever is given. Okay, we'll start with the left hand side. Okay, left hand side is sec square a plus cosec square a. Now sec square a can be written as 1 upon cos square a, cosec square a can be written as 1 upon sine square a. Now just cross multiply these two fractions. Sine square a times 1 is sine square a plus cos square a times 1 is cos square a, and in the denominator these two gets multiplied, so cos square a times sine square a. The numerator is sine square a plus cos square a, which is just 1, and the denominator is cos square a times sine square a. Now just flip it back again. Now there is obviously a multiplication sign, so we can directly flip it. So 1 upon cos square a is sec square a, and 1 upon sine square a is cosec square a, and that is what is my answer. Okay, next question. This one says prove that 1 plus tan square a into cot a upon cosec square a is equal to tan a. Obviously the left hand side looks bigger to me. I'll start with my left hand side, which is 1 plus tan square A times cot A, the whole thing upon cosec square A. Okay, first step we decided which side to start from. The second step, can I use any trigonometric identities? So yeah, I can see 1 plus tan square A in a bracket. So instead of 1 plus tan square A, I'll write sec square A. And then the cot A remains as it is and my denominator is cosec square A. Okay, now I can convert everything to sine and cos. So the sec square A goes to the denominator and it becomes cos square A. So this becomes 1 upon cos square A. The cot A can be written as cos A upon sine A, and that cosec square in the denominator comes to the numerator and becomes sine square A. Let us try to cancel out a few things. So I can see one of the coses can go away and one of the sines can go away. So what am I left with? I'm just left with a sine A upon cos A. Now sine A upon cos A is simply tan A, and that is exactly what is my right hand side. Okay, next question. This one says prove that tan square A minus sine square A is equal to tan square A into sine square A. I don't know where to start from. Probably I'll start with my right hand side. Let's see. Let's start with my right hand side. Doesn't really matter because both are almost identical in size. So tan square A times sine square A. Now tan square A can be written as sec square A minus 1. Okay, so tan square A is sec square A minus 1, and then I have a sine square A outside. We'll open up the bracket and the sine square A goes with both of the terms. So it becomes sec square A times sine square A, and then sine square A times 1 is sine square A. Now the sec square A can be written as 1 upon cos square A. So it is 1 upon cos square A times sine square A minus the sine square A. Now the first term, which is sine square A upon cos square A, which is just basically tan square A, and then minus the sine square A. Okay, you could do it exactly the reverse method also. If you start from the left hand side, you have to convert that tan to sine and cos, and then you take a sine square A common, just factor it out, and you just do the reverse process. It is like a very easy question actually. Okay, let us move ahead to the next question. This one says prove that cosec A times sine A into cosec A cosec A plus sine A times cosec A minus sine A is equal to cot square A plus cos square A. We'll obviously start with the left hand side because that looks bigger. Okay, so this one is cosec A plus sine A times cosec A minus sine A. Now we all can see it is difference of squares. A plus B into A minus B is A square minus B square. So this thing can be written as cosec square A minus sine square A. Now cosec square A minus sine square A looks really good to me because I know cosec square A can be written as 1 plus cot square A. So instead of cosec square, I'll write 1 plus cot square A minus the sine square A. I would just rearrange this and write it as cot square A plus 1 minus sine square A. So cot square A remains as it is. 1 minus sine square A we all know is cos square A. So I'll write cos square A, and that is it. That's my answer. Very easy. Also, just to mention that I am not writing the identities wherever I am using it. I will obviously mention it, and I am mentioning it everywhere. You should know that what identities I'm using because there are basically only 3 identities. Okay, and in your exams I would recommend you to write the identities. Okay, fine. Let us move ahead to the next question. Now this one says cosec A minus sine A into sec A minus cos A into tan A plus cot A is equal to 1. Obviously we're going to start with my left hand side, which is cosec A minus sine A times sec A minus cos A times tan A plus cot A. Okay, first step, any trigonometric identities, no powers, no trigonometric identities. Any algebraic identities, no powers, no algebraic identities. Any fractions, I can't see any fractions. The last step, convert everything to sine and cos. So this becomes 1 upon sine A minus sine A. Okay, this becomes 1 upon cos A minus cos A. The tan A can be written as sine A upon cos A, plus the cot A can be written as cos A upon sine A. Okay, This sine A is actually sine A upon 1 and this cos A is actually cos A upon 1. We can just cross multiply these and it becomes 1 minus sine square A upon sine A. This one becomes 1 minus cos square A upon cos A, and this one becomes sine square A plus cos square A upon cos A into sine A. Okay, now in the numerator I can see 1 minus sine square, 1 minus cos square, and the third one is sine square A plus cos square A. We all know sine square A plus cos square A is 1. We just manipulate the identities and the first one would become cos square A, because 1 minus cos sine square is cos square, and then the denominator, which is just sine A, times 1 minus cos square is sine square, so I'll write sine square A, and the denominator, which is just cos A, into sine square A plus cos square A would just be 1, and the denominator is cos A times sine A, so it is cos A times sine A. Let us try to cancel out a few things. I can see there is a cos square in the numerator and there are two cos's in the denominator, and everything is just getting multiplied. So these two cos's get multiplied with the cos square, and these two sines get cancelled out with, cancelled out the first one also. The two cos's get cancelled out with the cos square in the numerator, and the two sine A gets cancelled with the sine square A in the numerator, and I'm only left with a 1, and that is it. That's my answer. Okay, next question. This one says sine A plus cosec A the whole square plus cos A plus sec A the whole square is equal to 7 plus tan square A plus cot square A. Now we need to obviously start with the left hand side because that is bigger. Okay, so sine A plus cosec A the whole square plus cos A plus sec A the whole square. We decided where to start from. Can I use any trigonometric identities? No, because the trigonometric functions, that is sine, cos and all of those things, they do not have any power, so I can't use trigonometric identities. Can I use algebraic identities? Yes, because I can see it is a plus b the whole square and a plus b the whole square in the second bracket also. Okay, I'll just write the identity a plus b the whole square is a square plus 2ab plus b square. Okay, so the first bracket becomes sine square a plus 2 sine a times cosec A plus cosec square A. That is my first bracket. Plus, now the second bracket would become cos square A plus 2 cos A sec A plus sec square A. Okay, that looks really good to me. It's a huge equation, like a very huge line, but it's actually very easy. Let's see. The sine square A plus cos square A can become 1, so I'll write 1 instead of it. Okay, plus 2 sine A, the cosec can be written as 1 upon sine A, plus cosec square A can be written as 1 plus cot square A, because I can see in the answer there is a cot square A, so I can just write cosec, and I need to get rid of the cosec obviously. Okay, now the cos square A is already gone, plus 2 cos A is as it is. The sec A can be written as 1 upon cos A, plus the sec square A can be written as 1 plus tan square A, because I need a tan square A in the answer. Okay, now the sine A and the sine A goes away, cos A and the cos A just goes away. What am I left with? I'm left with 1 plus 2 from here plus 1 plus cot square A plus another 2 from here plus 1 plus tan square A. If I add all of these numbers, it is just 7 plus tan square A plus cot square A, and that's it. That's my answer. So in this question also, if you see, you just needed the trigonometric identities, the basic ones, and the algebraic identities. Simple as that. Okay, next question. This one says I have to prove that sec square A into cosec square A is equal to tan square A plus cot square A. Obviously the right hand side looks bigger, so we'll start with the right hand side. Okay, so this is tan square A plus cot square A plus 2. Can I see any trigonometric identities? Technically not very visible, but yeah, I can. What I would do is I would break the 2 and write it as 1 plus tan square A plus 1 plus cot square A. See, 1 plus 1 is still a 2, but I can use it as an identity. Now 1 plus tan square A is sec square A, plus 1 plus cot square A is cosec square A. Now I just need sec square A times cosec square A, and we have done a similar question in which we wrote the sec square A as 1 upon cos square A and the cosec square A as 1 upon sin square A, cross multiplied, and we got the answer. So I won't be completing this thing because you can just refer to that question. It's the same one. Okay. But the idea is that if you see a number and you can utilize it, you better go ahead and utilize it. Okay. Like the way I broke the 2 into 1 and 1. Fine. Next question. Now this one says prove that all of these is equal to that. Obviously I'll be starting with my left hand side. So the left hand side says cosec A upon cosec A minus 1 plus cosec A upon cosec A plus 1. No powers, so no trigonometric identities, no algebraic identities. I surely have two fractions which I can cross multiply, but just to make life a slightly bit easier for me, I will factor out cosec A from the numerator, and then I'll move ahead with my fraction cross multiplication. So cosec A is out, and then I have cosec A minus 1 plus 1 upon cosec A plus 1. Now I can cross multiply these, so it is cosec A as it is outside, and in the bracket it would be cosec A plus 1 plus cosec A minus 1, and in the denominator I can see it is difference of squares, which is A minus B into A plus B, which is A square, so cosec square A minus B square, so 1 square is just 1. In the numerator the plus 1 and the minus 1 just goes away, and I am left with cosec A times, in the bracket it is cosec A plus cosec A, which is 2 cosec A. In the denominator, cosec square A minus 1 we all know is cot square A because of the identity. Now the numerator is actually cosec A times 2 cosec A, so it can be written as 2 cosec square A upon cot square A. Now I will convert all of these to sine and cos, and it becomes 2. The cosec square comes to the numerator, the denominator, and it becomes sine square A. And the cot square can be written as cos square upon sine square. Basically, it is sine square A upon cos square A. Because cot square can be cos square, and in the denominator of the denominator is the sine square, which just comes to the numerator. I can just cancel out the sine square A and sine square A, and I am left with 2 upon cos square A, and 2 upon cos square A is as good as 2 sec square A, because 1 upon cos is just sec, and that is exactly what my question asks me for. Okay, next question. This one says prove that 1 plus cos A upon 1 minus cos A is equal to tan square A upon sec A minus 1 the whole square. I would start with my right hand side because that looks complex to me. Okay, so right hand side is tan square A upon sec A minus 1 the whole square. Okay, the tan square A can be written as sec square A minus 1 because sec square A is equal to 1 plus tan square A. So if the 1 goes to the other side, it becomes negative 1. So instead of tan square A, we can write sec square A minus 1. So this becomes sec square A minus 1, and the denominator still remains as it is. So it is sec A minus 1 the whole square. Now this one is actually 1 squared, and we can see it is difference of square, so it can be written as A square minus B square should be equal to A plus B into A minus B. So this becomes sec A plus 1 into sec A minus 1, and my denominator is sec A minus 1 the whole square, sec A minus 1 the whole square. Now I can get rid of one of the sec A minus 1 from the numerator and one of them from the denominator, and I am left with sec A plus 1 upon sec A minus 1. Now the problem is this is not exactly what I was expecting. So the rule is if it does not look like that but it looks similar to it, you just have to convert it into whatever it is. Okay, so sec A can be written as 1 upon cos A. So I'll write this thing as 1 upon cos A plus 1. In the denominator also it becomes the same thing, 1 upon cos A minus 1. Now these ones are actually 1 upon 1s, cross multiply it, and this thing becomes 1 plus cos A upon cos A the whole thing upon 1 minus cos A upon cos A. Now the denominator of the numerator and the denominator of the denominator, they both just cancel out, and I am finally left with 1 plus cos A upon 1 minus cos A, and that is it. That is what is exactly my left hand side. Okay, next question. This one again says prove that 1 plus sin A upon cos A into cos A upon 1 plus sin A is equal to 2 sec A. We'll start with my left hand side, obviously, because that is bigger. So 1 plus sin A upon cos A plus cos A upon 1 plus sin A. Same rules to be followed. Do I see any powers? No. If no powers, no trigonometric identities, no algebraic identities. Do I see two fractions? Yes, I have two fractions, which means I can cross multiply them. So 1 plus sin A gets multiplied with the 1 plus sin A. So it becomes 1 plus sin A the whole square plus cos A times cos A is cos square A. And in the denominator, they both get multiplied with each other. So it would be cos A times 1 plus sin A. Okay. Now in the numerator, I can see A plus B the whole square. That identity can be applied, which is A square plus 2 times 1 times sin A, which is just 2 sin A, plus B square, which is sin square A, plus the cos square A remains as it is. And I don't do anything to the denominator. I can just leave it. If you feel like you want to open up the bracket in the denominator, just ignore the feelings, because if you actually have to do it, you will eventually do it. But if you just don't have to do it, just like if the question does not require you to do it, then just leave it as it is. Why to bother? Okay. So this is 1 plus 2 sin A and plus the sin square A plus cos square A over here. It just becomes 1 and the denominator again stays as it is, which is cos A times 1 plus sin A. Now in the numerator, the first and the last one, they both become 2 plus the 2 sin A. Now I know at least half of you watching this would just say 2 plus 2 is 4, but it's not 4. You need to follow the BODMAS rule, obviously. Okay, so cos A times 1 plus sin A. Okay, what do I do? In the numerator, I can factor out a 2 and it becomes 1 plus sin A. Like both the terms gave away the 2's. In the denominator, I'm still left with the cos A times 1 plus sin A. Now, I can cancel out the 1 plus sin A from both the numerator and the denominator, and I'm left with 2 upon cos A. 2 upon cos A can be written as 2 sec A, because 1 upon cos is sec, and that is exactly what my right hand side is. Okay, next question. This one says prove that 1 minus sin A upon 1 plus sin A is equal to sec A minus tan A the whole square. Obviously, I can say that my right hand side is bigger or it is more complex. I can see an identity, an algebraic identity over there. So I'll start with my right hand side. So sec A minus tan A the whole square. Now, the general idea, according to our general rules, we should technically do A minus B the whole square over here. But what I would do is I would just do one extra step, because I can see my answer is in fractions. So I'll just convert all of these to sine and cos so that I get a sine which is required in my answer, and I get a fraction which is again required in my answer. So I write the sec as 1 upon cos A minus the tan as sin A upon cos A, and then I still have the whole square. These are like fractions, so I can combine them and write it as 1 minus sin A upon cos A the whole square. Now the square goes to the numerator and the denominator both, okay? Which means it is 1 minus sin A the whole square upon cos square A. Now, I would not use A minus B the whole square. I would just trick myself and I would say that sin square theta plus cos square theta is 1, which means cos square theta is 1 minus sin square theta. So in the denominator, I'll get rid of the cos square A and write it as 1 minus cos square A. So 1 minus sin A the whole square is as it is, and in the denominator I will write it as 1 minus sin square A. Now that 1 is actually 1 squared, and I can see a difference of squares. So it is 1 minus sin A the whole square upon that 1 minus sin square A can be written as 1 plus sin A into 1 minus sin A plus B into A minus B. So 1 plus sine A into 1 minus sine A. I can get rid of one of the 1 minus sine A's from the numerator and one of them from the denominator. And I'm finally left with whatever is required, which is 1 minus sine A upon 1 plus sine A. And that's it. That is my answer. Okay, very, very easy. You see, we defied a few rules. We said that we need to use the a minus b the whole square formula, but we did not do that because we were observant of the answer. So it is not necessary that you have to follow those rules. If you follow those rules, you'll easily reach your answer. But if you just look at the answer, you can probably manipulate those rules. You can manipulate yourself into not using those rules which I have given, and just make your way through the thing and get to your answer. Okay, because I could see that in this step there is a cos square and I don't need a cos. Okay, I don't need a cos in my answer. I need a sine in my answer. So I thought, okay, let's get rid of the cos directly, because I see a cos square which can be written as 1 minus sine square. Okay, so that is what it became, 1 minus sine square A. Okay, next question. Now this one again says, prove that cosec A minus 1 upon cosec A plus 1 is equal to cos square A upon cos A upon 1 plus sine A the whole square. I would start with my right hand side, which is cos A upon 1 plus sine A the whole square. Again, I would write it as cos square A upon 1 plus sine A the whole square. Okay. Now, again, I would use the same trick. I'll say that cos square A can be written as 1 minus sine square A, the whole thing, upon 1 plus sine A the whole square. So it is 1 plus sine A the whole square. Now, that 1 is actually 1 square, and this now becomes difference of squares, which is a square minus b square, which can be written as a plus b into a minus b. So 1 plus sine A times 1 minus sine A, and my denominator is 1 plus sine A the whole square. So it is 1 plus sine A the whole square. Get rid of one of the 1 plus sine A's from the numerator and denominator, and I am left with 1 minus sine A upon 1 plus sine A. Okay, now this is not what is required in the question. Like, the left hand side is not this, it is something else. We have done a similar kind of question where we convert it. How do I do that? I write it as 1 minus, the sine A can be written as 1 upon cosec A. In the denominator, again it is 1 plus sine A can be written as 1 upon cosec A. These ones are actually 1 upon 1s. Cross multiply it and it becomes cosec A minus 1 upon cosec A, the whole thing, upon cosec A plus 1 upon cosec A. Now the denominator of the numerator and the denominator of the denominator can just cancel out, and I'm finally left with whatever is my required answer, which is cosec A minus 1 upon cosec A plus 1, and that is it. Okay, so these many questions we had to do in this session. In the next episode, we'll do a few more questions, and then these are like the basic prove that questions. We'll do a few other questions which would try to, mess up with your brain maybe. And yeah, that's it. I'll see you in the next one. Thank you so much.